Welcome to Dora Tech Essential Series. Ease your learning.
In this video, we will learn about IPv4 and its usage. Every computing device that needs to talk with another device needs connectivity, either through a wired or wireless connection. Device connecting to a network shall have an unique identity at hardware level. As mentioned in our basic networking video, the unique MAC address plays the key role here. Each device participating in a network maintains an address resolution protocol table, ARP, which contains the neighbor device MAC address connected directly to the network switch. Though they have the hardware address of each other, they can't yet start talking to each other. That is where an IP protocol comes in place, which gives instruction to the hardware for communication. The above shown protocols are installed along with the network card installation. Many apps depend on them, and if there is no physical card, a virtual network card can be installed. The Microsoft loopback adapter will allow the system to use all of these necessary protocols. The IP protocol falls under the Layer 3 of OSI model. There is a detailed, advanced session on this topic. Coming back to IP protocol, we have two variants of IP address in use. IPv4 consists of 32 bits, and IPv6 consists of 128 bits. IPv4 usage began in early 80s, and they were quickly leased by multiple companies/organizations. By 90s, we were running short on public IPs in IPv4 range, which lead to a bigger range requirement. IPv6 was introduced in late 90s as future-proof, considering the number of devices coming online. There is a separate video on IPv6. Let's focus on IPv4 first, for better understanding. The IPv4 is made of 4 bytes, that is 4 into 8 bits, equals 32 bits in total. Each byte is referred as an octet, and is separated with a dot. The IPv4 follows decimal representation of the bits. That is, all zeros sum up as 0, and all ones sum up as 255, providing 256 values. 32 bits provide approximate 4.3 billion IPs in IPv4. The above chart shows each bit value from right to left. Please refer the basic binary video on my channel for more info. The 4.3 billion IPs can't be on a same network, as it will create a tremendous bottleneck due to broadcasts. They are split into multiple networks, some small and some big, based on the requirement. The size of the network depends on the number of hosts or machines it can have. The host bits are reserved from the right-hand side. The above chart shows how many IPs we can get by reserving the bits. It's always n-2, as we have the network and broadcast IPs reserved for every network. As we are clear about the octet, network bits, and host bits, let's focus on the standard classes, which are predefined in IPv4, and their usage. The classes are reserved with the network bit of the IP range. The first octet is reserved for class A, 8 bits. 2 octets for class B, 16 bits. 3 octets for class C, 24 bits. 4 octets in class D, 32 bits. Class E is reserved for research and military purposes. Each IP represents a network in itself in class D and E. The chart above shows the start and end IPs under each class, and their respective subnet mask. There is a separate detailed video on subnetting and supernetting. The network ID starts from left octet, and each octet contains 8 bits 256 values. We can't give all bits to class A, as there will be no more left for other classes. Hence, the first bit is locked in class A, and the rest 7 bits are used. 7 bits provide 128 decimal values, i.e. 0 to 127. Since we have utilized all the 7 bits in class A by setting it to on position or 1, we need to set them to off or 0 to move to the next range. Hence the 8th bit is set to on, and the rest bits will become off, which gives the value 128. The network containing all zeros represents all networks in IPv4, and network containing all ones represents as broadcast address. Hence these two networks are not used for IP assignment. So the actual range for class A is from 1 to 126. 127.x.x.x is reserved as loopback address, used by applications for self-communication. Class B reserves the first 2 bits from the leftover range and allows 6 bits in first octet. This provides 64 values in total, i.e. from 128 to 191. The second octet is used completely. The total networks in Class B are 64 multiplied by 256 equals 16,384 networks, and 65,534 hosts each. We again need to reset the ones to zeros by moving the on bit one step further, which provide us the decimal value 192. Class C reserves the first 3 bits and allows 5 bits for use, providing 32 values. Hence the range is from 192 to 223, and it uses 3 octets in network portion. This allows 32x255x255 equals 2,097,152 networks, with 254 hosts each. A commonly used size. A decent network is considered up to 500 hosts, as anything above it will bottleneck with broadcasts. Class D reserves first 4 bits, and allows 4 bits for network, giving 16 values, from 224 to 239. It follows the same bit carry forward pattern, and uses all 4 octets, hence there are no hosts in it. It's mainly used for multicasting purposes by apps, e.g. online radio channel, live streaming, etc. People who tune into the app will get those live stream through the app/API assigned IP. There is a dedicated video on broadcast, multicast, and unicast. The remaining IP range are reserved in Class E, and mainly used for research and military purpose. A part of the bit reservation we've seen so far for all classes. A subnet mask is assigned to each class, which divides the network and host bits in an IP range. The first octet is reserved for Class A, 2 octets for Class B, and 3 octets for Class C, which gives us the values as /8, /16, /24. The remaining bits are available for the hosts in a network. As mentioned earlier, a healthy network can have up to 500 hosts in it. The Class A and Class B range exceeds this limit, hence they are broke into small chunks. This is known as CIDR, classless interdomain routing, or subnetting. There is a dedicated video on subnetting and supernetting. Hope you enjoyed the series. More to come soon. Like, share, and comment. Press the bell icon and subscribe to get notified about upcoming videos.